Assalamualaikum and good evening. I'm AZIQ MAHADI. Today we are discussing our project Automated Inline Vision Inspection System presented by Group O. We will cover I will cover for introduction and background, problem statement and project objective. So let's begin. So next slide. Our main topic is transitioning from manual to automated quality assurance. Current manual methods are prone to human fatigue, inconsistency, subjective judgment. So this led to undetected defects, rework and delays. Our solution is an automated in line vision system that use high resolution industrial camera, machine vision algorithm, real-time inspection without stopping production. They support smart manufacturing and integrate with systems like PLC and SCADA. So next slide. For problem statement, let's break down the core problem we are addressing. So first, the throughput bottleneck. Manual inspection cannot consistently match high-speed production rates, creating a physical bottleneck that restrict overall manufacturing throughput. So second, subjectivity and variability. Human inspectors are prone to fatigue and distraction, leading to inconsistent inspection outcome and dimensional inaccuracies. So, uh, for no-real analysis and inability to predict failure. So next, high operational cost from rework and waste. So last, traceability challenge. Traceability challenge. Without automated logging, there is limited traceability, making it difficult to support data-driven decision making or comply with modern industry quality standards. So our objective is primary goal enhance quality control while reducing human dependency. So we have three KPI. So first, achieve a defect detection accuracy of at least 99%. So second, reduce inspection time by minimum of 50%. Last, reduce overall defect rate by 30%. And now I pass to my friends.
Hi, I'm ALISA ZAHIRAH from Group O. So I'll be presenting about the WBS work breakdown structure. On this slide, I want to show you how our team has organized the work. For the first step is project management. We'll be watching the budget and making sure we stay on schedule. And then the second one is system design. This is our planning phase. We will pick the best cameras and lights to make sure the system sees every detail. And then the third one is hardware and software. This is when we build the brain of the system. We will buy the equipment and write the code that helps the cameras find mistakes. For testing, before we finish, our team will run many tests. We want to make sure the system is working perfectly. And finally, for the last phase is training and maintenance. We will teach our team how to use it. We will provide manuals and maintenance plan to keep everything running for a long time. This is to ensure a long-term sustainability. Okay, move on to the next slide. Next slide is about project timeline and critical milestone. This is our 7-week roadmap to get the system started. So on week 1 until 2, we start by studying the current manual lines. We want to find the gaps so we can make the new system even better. And then on week 3 to 4, during these weeks, we finally finalize the design and buy the hardware. We are managing a budget of about 250,000 ringgit for the equipment. And then on week 5 to 6, this is when we install the 8 high-speed cameras and sensors. And then integration with existing PLC and SCADA system. We have planned this so we don't stop our daily work. And then in the last week, we perform factory FAT and the site acceptance test SAT. Our team's goal is to reach 99% accuracy when we hand the project over to anyone who use it. So that's all from me.
So my name is Hafiq with ROSLI, and I'm going to talk about the financial breakdown and the cost distribution and also the funding resources. So for the financial breakdown, there are 5 categories, which is material cost, labor and installation, testing and training, contingency fund, and lastly, drain total. For the material costs, the cost is 50 to 250,000 ringgit. The key components include 8 high-speed industrial cameras, multi-angle ALD lensing, GPU vision unit, and optical fibers. For the labor and installation, the cost is 204,000 ringgit. It is component. The component is system design, software development, and physical hardware integration. For the testing and the training, the cost is 120,000 ringgit. The the component is system validation, operator training programs, annual software licenses, and documentation. And then the contingency fund. The cost is 57,000 ringgit. The components include a 10% reserve allocated to mitigate the unforeseen technical challenges or supply chain issues. And then lastly, the grand total, which is 631,000 ringgit. The total project investment is required for full pilot implementation. That's right. Now it's about funding sources and financial management. For the funding sources, there are 4, which is the government automation grant, corporate sponsorship, payment subsidy, and lastly monitoring tools. For the government automation grant, the amount is 180,000 ringgit. The management strategy is that it subsidize funding for Industry 4.0 adoption. And then corporate spreadsheet, the amount is 51,400 ringgit. It is for the external partnership support. And then payment strategy, which is for support with 40 and 40 and 20%. The 40% is upfront for the procurement. The other 40% is upon installation, and the last 20% after the final training. And lastly, the monitoring tool. The amount is about the real time. It is manually reduced and tracking via Excel dashboard or the Click books. Next slide. The project outcomes for the activity. It is achieving a minimum detection accuracy of 99%. The quality targeted 30% reduction in overall product defect. For stage, is reducing inspection cycle time by at least 50% compared to manual method. Waste reduction, minimizing material waste, and increasing throughput. And lastly, Industry 4.0 integration. Seamless communication with digital PLC and SCADA system for better data and traceability and smart manufacturing. So that's all for our group. And that's all for this meeting. So we can dismiss. So thank you for listening to our meeting.